All right, now we are going to look at how we can use our calculators to use some data tables and some information that that can give us, okay? So in this first example, I am looking at a table that shows me the height in feet of a falling ball that's above ground, and I'm measuring it by a motion detector, and I'm measuring it every 400ths of a second. So every 400ths of a second, and you can see that the object is going down at 400ths of a second at 6.8 feet above the ground, and 800ths at 6.4 feet, da 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 da. Okay. So the first thing says to estimate its instantaneous speed of the ball at t equals 0.2 seconds. Okay, so kind of one thing you can do is you can kind of realize this. At 0.2 seconds above the ground is the midpoint between 0.16 seconds and 0.24 seconds. Okay, so you can estimate this like this. Okay, we're going to do rate of change for this, okay, as a good approximation. So this is what I want you to think about. I'm using kind of this coordinate right here, and I'm using this coordinate right here. Okay, and if I want to estimate the rate of change, then, and I just kind of did that, 0.2 is the midpoint between 0.16 and 0.24. So that's why I'm using those two coordinates, because 0.2 is the midpoint between them. So what I will do is I will think of this as a coordinate, which is 0.16 and 5.45. And I will think of this as a coordinate, which is 0.24 and 4.3. Okay, and I will find my average rate of change in there, and my instantaneous velocity might not be the same, but I'm just going to say that if I find my average rate of change, and at a point that's halfway between those two, it might be a good suggestion. It might be. Okay, so here we go. Let's do that. Basically, we're finding slope. Okay, so I'm going to go 4.3 minus 5.45 over 0.24 minus 0.16. When I do that, I get negative 14.375. And it does make sense that your slope would be a negative number if the object is falling. Okay. Um, Part B says to draw a scatter plot of the data and use the quadratic regression model to model the height. And then once you have that, then you can find the derivative at 0.2, and the derivative will give you hopefully some information. Okay, so here's what we're going to do. We are going to take this data and we're going to put it into our calculators. So if you remember, you're going to go over here. You're going to hit Stat, and you're going to hit Edit. And remember to clear out a list. I already have this data in here, luckily. To clear out a list, you'll up arrow until the name of the list is highlighted, hit clear and enter. You can see that I have entered that data in mine into list 1 and list 2. Okay, so you can hit pause on the video. You can practice this by getting your data into list 1 and list 2. Once you get that, then you need to make a scatter plot. Okay, so I'm going to make a scatter plot by doing stat and then, sorry, not stat, scatter plot. Second y equals, that's what I want. And by the way, I'm going to go up to y equals and see if I have a function in there. Let's clear it out. So we're going to clear it out of there. Okay, now I'm going to go second y equals, and I want to go into number 1. I want to turn it on. My data is in list 1 and list 2 for this. If your data is in a different list, then you need to change it. Remember that your names of your lists are down here above the numbers, so you need to press second or whatever to get to them. But here's my scatter plot, and I am going to go ahead and graph this by hitting zoom 9. Okay, so clearly you can see that something is not right, because it should end up, well, maybe it is. It's not a straight line. Yep, nope, it is right. It's not a straight line, so you don't want to use linear regression. I think hopefully you can tell that it is curved, and it's pretty subtle, but you can tell that it's curved, okay? Because it's a curved line, we are going to do quadratic regression instead. So just so that you remember how to do that, what you're going to do is you're going to do stat over to calculate. And we want to do quadratic regression because it's not a straight line. If it was a straight line, we would do linear regression, but it's not. So we are going to do quadratic regression, which is number 5. Okay, my data is in list 1 and list 2. If you need to change where your x and your y's are, go ahead and change that. Then one thing I'm going to do is I'm going to store this regression equation, and I don't know if you've ever done that before, but we're going to put it into our y1 graph so that you can see this. So what you're going to do is this. You're going to go down to store, and you're going to go to variables, which are right here, okay? And then over to y variables, and then you want function. So number 1, oops, sorry, it's kind of let me, okay, so number 1, and then you want y1. Okay, so what that's going to do is it's going to put your equation that it calculates into y1. Okay, so here is the equation. First of all, if you can memorize it, you can certainly write that down and plug that all in, or you can just go up to y equals up here, and it's already in there for you. Okay, it's already in there. The only reason I need that, and by the way, you can just on part B, just sort of estimate this. Your regression equation becomes about negative 17.12 t squared minus 7.74 t plus 7.13. Okay, so it's about that. Then it says use the numerical derivative to approximate the derivative at point 2 and compare it to the value that you found in part A. So I want to find the derivative of that quadratic regression equation. So I'm going to teach you something else on your calculator. Okay, I'm going to go back to the main screen. I know you already know how to find the derivative. The derivative you get by doing math, and then I would want number 8. And then instead of typing that function all in again, since it's already stored in y1, you can just tell your calculator to pull up the equation from y1 again by doing variables. Over to y variables, you want function, and you want y1. So you're telling your calculator to pull up the function that's in y1, and you want to do that at 0.2 seconds in this case, remember? Go ahead and hit enter, and we get negative 14.585. So not too far from what we did our estimation at. All right, then if we continue this problem, it says that it gives us that same piece of data again, and it says compute the average velocity on each subinterval of length 0.04, make a table showing the midpoints of the subintervals in one column and the values, okay? This is what I want you to do. This may be just a little bit complicated, but here's the deal. If I look at just these two intervals right here, the midpoint is 0.06, okay? And then to get this number right here, what I'm going to do is I'm going to do the rate of change. So I'll do 6.4 minus 6.8 over 0.08 minus 0.04 because those are my x values, and I get negative 10 when I do that. Okay, and it wants me to keep doing the same thing. The interval between there and there would be 0.14. To get this number, I would do, find the slope basically between those. Okay, I've already done that for you just so that you can see that, and that's how I got this number. Okay, or this table. So the midpoint was 0.06. When I found the slope between those 2 points, that's what I got. Okay, so there's my table that I've already created for you, but that's how it got created, just so you know. Okay, then it wants me to take that data and make a scatter plot of it. So I will stop right there. I will make a scatter plot of that data. So I'll go right here. Again, go stat, edit, put your data in. I've already got my data in. It's over here in list 3 and list 4. So you can go ahead and hit pause and put your data in just so that you can practice this. Okay, and I want to make a scatter plot of the data that's in. Mine's in list 3 and 4. You can put yours in 1 and 2. It doesn't really matter. But first of all, I'm going to go up and I'm going to clear my y1 equation out so that it's gone from the last problem. And I will do a scatter plot. I want to go in here. It's on, but my data is in list 3 and list 4. Okay, I'll go ahead and hit graph. Oops, I forgot. Zoom 9, sorry. All right, this does look like it's a linear model. Okay, it does look like it's pretty much a straight line. I know there's some weird outlier kinds of points in there, but it does look like it's a straight line. So I will do linear regression. So I will do stat over to calculate, number 4 in this case. And my data is in list 3 and list 4. Okay, I do want to store my regression equation. So I'm going to hit variables, over to y variables, function, y1. So I'm going to store it in y1. I'm going to go ahead and calculate it. Okay, there is my linear regression equation. So I'll just go ahead and record that here. My linear regression equation was about negative 34.470t minus 7.727. Okay, and then it says use the linear regression equation. I'm going to just do this. Use the linear regression model to approximate the velocity of the ball at t equals 0.2. Okay, again, if you're approximating that velocity, you're going to do the numerical derivative at 0.2. Okay, you're going to stick that into your calculator and go ahead and plug that in. So I'll practice that with you right here real quick. I'm going to go to the main screen. I'll hit stat. Oh, sorry, not main screen. I'll hit, yes, main screen. But I want math, that's what I want. Numerical derivative, dx of the function that's in y1. So I'm going to do variables, y variables, number 1, y1. And I'm going to do that at 0.2. And I should get negative 34.47. All right, then we have one more to do really quickly. All right, this is another example. It says it shows the velocity of a moving body measured at 0.25 second intervals, and then it wants to estimate the distance traveled by the body from t equals 0 to t equals 3.75. So if it wants distance travel, that means you're going to want to do an interval. Okay? So the first thing you want to do is you want to make a scatter plot. Then you're going to get the regression equation. And then you're going to find the integral of that regression equation in the given interval. Okay, so lots of steps, but that's what you do. All right, so first you're going to go to your calculator. You're going to put that data in. So stat, edit. I already have my data in. My data is in list 5 and list 6. Okay, so I'll go over here to list 5 and list 6, and there they are. And so I'm going to go ahead and make a scatter plot of that. Again, I'm going to clear my y1 out from before. Okay, so I'm going to go ahead and make a scatter plot. So I will go second y equals I need to turn it on. My data is in list 5 and list 6. Yours might be someplace different. I will hit zoom 9. Okay, there's my data. So you can see it's a parabola shaped, so I definitely need to do quadratic regression in this case. So I will do quadratic regression, okay, so that I can come up with an equation for that line, basically, is that curve. I'm coming up with an equation of that curve. And then if I want to know the distance that the object moved underneath that curve, I'm finding the area underneath that curve, which is the same as doing the integral. Okay, so I am going to do stat, over to calculate, quadratic regression in this case. Again, my data is in list 5 and list 6. I'm going to store this baby again. All right, and I'll go ahead and calculate it. Okay, so there's my regression equation. I can see it. If I go up to y1, it's also stored in y1, so it's there. Okay, then I'm going to go back to my main screen. I'll do math. I want to do the integral, which is number 9, and I'm trying to figure out how much the ball is moving from 0 seconds to 3.5 seconds, or 3.75 seconds. So 0, 3.75. I can go ahead and type in that linear regression equation, or I can just tell my calculator, pull it from y1 for me, so that I don't have to retype it. So that's what it's going to do, and I have that in there as an x. Go ahead and hit enter, and I should get about 3.16, okay? And if you look at this problem, it does not, in meters per second. It says, shows the velocity of a moving body in meters per second. So distance traveled in this case is going to be in meters. And that's this lesson.